Okay, so the next one says find the volume of the solid of revolution formed by revolving the region bounded by x minus x cubed and the x-axis. Oops, moving it. So right here, about the y-axis. So we're going around here. So do you guys see how this one would be hard to do with the disk method? Because you'd have to do an outer radius, and then an inner radius is the other side of that little parabola part. Yeah, don't do that. So let's do the shell method. Okay. So since it's a vertical axis, we're going to use a vertical rectangle. Its distance is x, so that's my radius. We're going to talk about when the radius isn't x or isn't y soon. The height of your rectangle is the x minus x cubed. So my volume is going to be 2 pi. My radius was just x, so that's the radius. My height is the x minus x cubed. Since we're talking about adding up all of these different x values, so these rectangles with different x locations, we're going from 0 to 1 for the x's. Okay, multiply the x in, you get x squared minus x to the fourth. Integrate, so you get x cubed over 3 minus x to the fifth over 3, or 5. With 2 pi out front, going from 0 to 1. So that's going to be 1/3 minus 1/5 times 2 pi. So it's 4 pi over 15. Okay. I'm pretty good on when the radius is just the distance from the axis. You guys understand that?
Very simple.
It's confusing because a lot of people do confuse it with the disk method. So you really have to have disk method down before you kind of move on to the shell method. So hopefully you guys have it down now. I hope. All right, so let's do one where the radius isn't one of the axes, or where the axis of revolution isn't the x-axis or y-axis. So it says find the volume of the solid revolution formed by revolving the region bounded by 8x minus 2x squared. That's this top parabola. And 4x minus x squared, that's the bottom. That's this one. You're going around x equals -2.
So which one is making the shape? Are they both making?
This is the top one. It's twice the height, right? If you multiply by 2, that's how you got that one from the first one. So it's like a vertical stretch by 2. That's why it's stretched out. It's this one. Mm-hmm. All right, so this is our region that we're rotating around x equals -2. Okay, so always think vertical axis or horizontal axis. So this one's a vertical axis. So we're going to use a vertical rectangle. So just draw the rectangle in wherever, it doesn't matter. Okay, my radius is always the distance from the axis that I'm rotating around. Okay, so you see the line that you're rotating around? Mm-hmm. So your radius is going to be x, because it would be from 0 to that red rectangle is x. But then you have minus the -2. So x minus a -2 is x plus 2. Do you guys see? Because it was x and then you added 2 more to it. Good job, Katie.
I see.
Okay.
Is that the radius of the rectangle?
Yeah.
Oh,
Well, it's not the radius of the rectangle. It's the radius of the shell that you're creating when you rotate the rectangle around.
oh, okay.
Did you see the shells over there? So it's like the radius of that shell that we had.
From like the center to the nose.
From the center of rotation to that rectangle that we're rotating.
So like the middle point.
So here was our rectangle we had, and we rotated around. You guys see, so that's the radius from the center to that rectangle. Okay. What's the height?
Is it 8x minus 2x squared minus 4x minus x squared?
Yep, that's right. You guys see it? So it's the top curve minus the bottom curve. It's 8x minus 2x squared
That's
minus 4x minus x squared. Okay, so when you simplify that out, you get 4x minus x squared. Good. Brian's on top of it. So we get 2 pi r. I sometimes pull the 2 pi out to the front, but it doesn't matter. R is your x plus 2. The height is 4x minus x squared. And my x values go from 0, so we're talking about what's been the x values of the area there. 0 to 4. Do you guys see?
never get
You never get the x values.
limits of integration. Like I always think, oh, I should use the y for the x's, but I'm just kind of like.
Yeah, do you guys see? It's the corners of that region that you had. So 0 to 4. Those are the x values. Is it? I don't know. I thought the Star Trek symbol was like the fingers.
Oh, the other way.
You mean Starfleet?
No. Start.
Alright.
I knew it. Come on, you're the Trek.
Know your trick.
My dad's the Star Trek.
Okay, I'll let you guys use Math 9 on this one. You can FOIL out though. It wouldn't be too bad.
2x squared minus x cubed plus 8x.
So if you use your Math 9,
256 pi over 3.
you got it.
My dad got on the set. He sat me in the chair.
You see how much time?
Oh God.
Okay. So 256 over 3 times pi. All right. Next up. Okay, your picture on this one's on the other side of your notes. It's kind of confusing. I should have just moved the whole thing. All right, this is the hyperbola. So it's this. Okay, x equals 4 is this line. So the region that we're rotating is this. We're going around the line y equals 5. I'll draw it in blue. Okay, so since that's a horizontal line, we use a horizontal rectangle. So draw on a horizontal rectangle. Okay, so let's think about it. When we had the disk method before, whenever we had a horizontal axis, like the x-axis, we integrated with dx at the end, right, with respect to x. So now we need dy. So I'm going to have volume, and I'm going to have a dy on the end. So I need my equation in the form x equals. It's on the back of your notes, Kwame.
I see.
All right, so we need x equals something. Shh, guys. All right, so here we need to solve for x. So I'm going to add my y squared over. I'm going to take the square root of both sides. And when I take the square root, you have to write plus or minus, right? So I have plus or minus the square root of 7 plus y squared. Okay, so let's think about it on our picture. When are my x's the positive ones? Over here on the right, right? So this is the curve x equals positive square root of 7 plus y squared. when our x is negative, over here on the left, so this is x equals negative square root of 7 plus y squared. Make sense? So those are the two curves we got out of solving that for x. Okay, so let's talk about the radius of my shell. So what do you guys think the radius is? 5 minus
5 minus x.
5 minus y. You guys were right.
Minus y.
Oh, actually 5 minus, yeah, it is 5 minus y. All right. So it depends on where your y value is located. If you were at 1, this whole radius would be 4, right? If I was located at 3, the radius would be 2. All right. Now my height of my shell, what do you guys think that is?
7 plus
I heard someone say 4 minus, what was it? Square root of 7 plus y squared. It's the right minus the left, just like when you'd add area of that little figure. So we need to write right, left. Okay, so let's put it all together. So I have 2 pi. My radius is 5 minus y. My height is 4 minus the square root of 7 plus y squared dy. My y values, where do your y values go from?
Where those intersections are.
You could do 3 to 5. Oh, no, it's positive.
Was that negative 3?
We need negative 3 to 3.
Negative 3 to 3, right. Now the question a lot of people always say is, can you just do 0 to 3 and multiply by 2?
Yes.
It looks like you could. It's making like a donut and it's very symmetric, so you probably could. All right. Actually, I don't think you could. This is like the inner part of the donut and the outer part of the donut. Do you guys see? Like, if I have a donut, the volume from here to here is not the same as the volume on the outer part. Do you guys see? So be careful on this. Cream. All right, so when you do this to your volume, you get an answer of, it works out to be a weird number, 51.893 pi. It doesn't work out to be like a nice fraction. So when that happens, I usually just I multiply the pi in. So I get 163.027. So I'd use that. All right. Okay, I have homework for you guys.
Yay.
Yay.